Hello everyone. Welcome all to our session. So today we have with us Jeshri Gupta. Welcome, Jeshri Gupta. Everyone, welcome. She is upcoming DC intern at Google. She is also Beta Microsoft Learn Student Ambassador and also chapter lead at Girl Script. So I welcome Jeshri Gupta for a lovely session. She will be guiding you through the bootcamp. Over to you, Jeshri.
Yeah, thank you so much, Itasha, for giving my introduction so well. Just let me know whether my screen is visible.
Yes, it's visible. You can go on.
Okay. So, hello everyone. Welcome to the Microsoft Azure Fundamentals Bootcamp on exam DP 900. So, basically, first of all, let me tell you that why this exam is for, like, for whom is this exam is conducted, and who can take the certification of this exam, right? DP 900 is basically for the people who want to explore the field of data. Like, it is basically for the people who want to go in the field of data in the cloud. Okay, so this TP 900 exam is sponsored by Microsoft, and its certification is provided by the Microsoft itself. So you need to score, like, total score is 700, like passing score. So you have to score that much for passing this exams, and it basically cover all the basic concepts of the data. So that we'll discuss in these 3 days boot camp. Okay. I think we should skip my introduction. So as Itasha has already introduced me, let's start with the session. The contents that we are going to see is the core data concepts, then roles and responsibilities in the world of data, that the jobs that are available in the field of data, then concepts of relational data and non-relational data, and the core concepts of the data analytics. Okay, so let's start. Like, I want to ask you that what a data is. Like, most of you know that what a data is, because it's a very common term nowadays and everyone knows it. More specifically, let me tell you that whenever, suppose that you are going to a market, okay, so and you are making a list of the items that are gonna purchase from the market. So that list is your data itself. So anything that is the collection of the things, like pictures, numbers, words, keywords, anything, the collection is known as data itself. Okay, so and from that data will make some useful information. So any raw collection, we could say, is a data that we have. Now we have data, like we have words, we have photos, we have videos, and lots of collection. Okay, so data is been classified into three categories basically. One is like structured data, then semi-structured data, and unstructured data. Okay, so let's see. Structured data. So basically the data that we have in the form of the tabular format, like basically any data that is stored in a tabular format is the structured data. Like it is, the data is stored in the form of rows and columns, like it is holding your like column ID, then like a customer ID, then customer name, or anything, any data in the form of tabular like format. So it is known as structured data. Then coming towards the semi-structured data. So like any document, like data in the form of documents we have, like text documents or like any other documents. So that data is the semi-structured data, because that is not in the available in the form of tables. So like the data in the form of a JSON format, like our JavaScript object notation. So it is basically considered as semi-structured data. Then we have unstructured data. So like all the data that includes audio files, video files, photos, or anything like which doesn't have a particular order, or we could say particular structure, then it is known as unstructured data. Now, how is data defined, stored, and accessed in the cloud computing? So before going to this, so let me tell you what a cloud computing is. So cloud computing is a technology, like how we are handling our data over cloud, like how is data being stored, managed, and like processed over a cloud. So it is known as cloud computing, like whole process, whole technology, you could say. So now coming towards like how data is being stored at cloud. Okay, so like as we have described that data is being in the three forms, like structured data, unstructured data, and semi-structured data. So like based on the basis of their forms, these data is also being stored in different manner over cloud. Okay, so like firstly we have structured data. So structured data is typically stored in the form of relational database. Okay, so like if we could talk about in the terms of Azure, so it is stored in the servers like Azure SQL database. Okay, and we generally use SQL queries to process our data and to access our data. Now, coming towards the unstructured data. So, unstructured data like audio files, video files, and these all these things that are not structured, like unstructured. So, these are stored in the Azure Blob storage. Blob is a binary large object basically. So like we will discuss these terminologies in our next session, so like I'm just giving you a basic idea about it. Then coming towards the semi-structured data. So semi-structured data includes your documents, and we use Azure Cosmos DB for this. Okay, let's move ahead towards the data processing. Now we have our raw data. Okay, now we want to have our useful information from the data we have. So the technique that is used to convert the raw data into a useful information is known as data processing. Okay, so data processing is a basic process, or we could say method, or several techniques are there for data processing to process our data, to convert the raw data into a useful information. So we have basically two broad categories for the data processing solution. Okay, so like as data is divided among different parts, so we have different techniques for that as well. So like we have analytical systems and transactional processing systems for that. Let's see what is a transactional system. So basically the transaction system means that your data is being used for the transactional queries, for your transactional processes. Like for example, generally in general manner, all the tabular form data that we call relational data, or we could say structured data, is used for the transactional system. Like in banking we use this data, in your like e-commerce website we use this data for transaction. So every data that is used for the transaction, it is used as transactional system, in the form of transactional system, to process that data into a useful information. Okay, so like this transactional system stores the all the tabular data, and it is further used for the banking and for business computing, we could say. And then transactional system are of high volume because they contains the lots of data, and that are most of them are confidential because they contains your user ID, password, bank ID. So like they are more of confidential as well. Okay, then we have analytical system. So analytical system are concerned with the raw data, like data in any form which is further used to generate the insights. Like for example, like data that we use to create a survey, the data which we use to create the trends, or for business purpose, for visualization, and for querying, and to storing the any details like that. So that in that purpose we use analytical system. Okay, now like here in this diagram we could see that first of all we have critical device data, then financial transaction, then point of sale data, and all these raw data is being data ingestion. That means it will be transported for the processing. Then after data transformation, like after whole processing, and after making the useful data from it, then it is further passed for either queries, or for either visualization. Okay, so Now coming towards the transactional workloads. So basically, as I have mentioned, that transactional workloads, like transactional system, involves the relational data, because all the data that is in tabular format, that is in structure format, we use for the transactional workloads, for the transactional systems. Okay, so a transactional database must have to follow the ACID properties, because ACID properties plays a very important role for the transactional management. Okay, for transactional queries as well. Now, what ACID properties is? So, ACID properties, ACID is a basic acronym for atomicity, consistency, isolation, and durability. So atomicity means that, for example, if you are doing any transaction and your transaction must not stop in between, and if it stops in between, then it must start from the restart. Okay, that means, for example, you are paying from your any bank account for any e-commerce site. Okay, and you have lost your internet connection in between, then that transaction will not continue from that particular point. It will restart again whenever you have a good internet connection. That means it must follow the atomicity. Okay, then we have consistency. Consistency means that the values or the data must be consistent. That means that, for example, you have 15,000 rupees in your bank account. Okay, and you have like deposited 500 rupees in that. Okay, so you have now 15,500. Then the values that have updated must be consistent. It should showing the correct values, so it is called as consistency. Then we have isolation. So isolation means separation. So isolation means like we have like, for example, I'm working on my database and you are working on your database. So the changes that have made to my database should not reflect to your database. So that means that it is following the isolation. So isolation is again plays a very important role for this. Then we have durability. Durability means permanency. So durability means permanency, because the permanency in the values are very important. For example, as I have told you that we have 15,500 rupees in our account. Now again, after 10 days, I'm checking my account details and it's showing that it's only have 14,000 rupees. So it will not work for me. Like, I will say, where my 1,500 rupees have gone. So for that, durability is very important. That value must be permanent. Any changes are done must be permanent and should be durable. Okay, then for transactional workloads, as I've mentioned, that it must be complex because it must handle the data that are confidential as well. So it must be confidential and it must be complex. Okay. Then we have analytical workloads. So analytical workloads are typically read-only systems. That means, like, for example, we are using a data to create a survey form. Okay, we are using a data to create a trend. We are using a data to make a chart, like graph, or we are using data for creating any pie chart. So the user will see that pie chart only in the read-only form, and it will not edit it. Okay, and like for example, in business we use for trends, we not see the raw data that is available, because raw data will contain a huge list. So we see only the charts and only the graph that is available. Okay, so analytical workloads basically are for read-only purpose, as and they contain any much confidential information in them. They are generally used for business information, for summaries, for surveys, for trends, and for that purpose only. And we could say that transactional information is the integral part of the analytical information. Okay. Now, moving ahead towards the batch processing. Now, we have studied about the transactional and that analytical system. Now, coming to the processing technique. So, as I have mentioned, that data processing is simply a conversion of raw data to the useful information. So, for that, we use two techniques. So, first, we have batch processing. So, what a batch processing is? Basically, whenever a user enter the information or enter the data, whenever there is a data, recent data we have available, so we have to process that data. So in batch processing, what happen is that data is collected together and they are assigned a batch. They are assigned together in a group, and that group is known as batch. And further, the processing will take place on that particular batch itself that contains the recent added information, data, all the data. Okay, then further the processing will takes place on that huge batch. Okay, now batch processing will be work over the large volume of data because it makes the batch of the data, so the group of the data, so it will be work on the large volume of data. Like it's a one of the advantage of batch processing. And coming towards like its timing, so like it will be take time because the processing will take place on huge batch, on huge group of data, so it will definitely take lot of time to execute that, to process that data. Okay, now coming towards the second technique. So second, we have streaming and real-time data. So in stream processing, what happens is in this the user whenever user enter a data, then the recent data is being processed. Okay, then recent data is being processed. So a small unit of data is being processed. So but here no batch is divided, no group is made, only the data comes, it just processed and then pass on. So this happens. So here the time consuming is very less, like it will process the data in a few seconds or milliseconds. And here, but here the problem is it is beneficial for the small amount of data, and the data must be in continual basis, like it must be coming together. Okay, now coming towards the difference between batch processing and stream processing. So talking about in the terms of data scope. So basically the batch processing can process the all the data set together. Okay. Talking about the stream processing, so typically it will access the only recent data, only the single small unit of data, and it will process that. So coming towards the data size. So in the terms of data size, so batch processing is suitable for handling the large data set for the huge batch or group, we could say. But stream processing is just for individual records or for the small or micro batches, we could say. Now coming towards the performance. So performance depends on the time taken for the processing. So for batch processing, the time taken is few hours or like in terms of hours. Okay, because here the whole batch is being processed together. But in stream processing, it will take a few milliseconds or we could say few seconds because here the single unit is being processed again and again. Now coming towards the analysis. So if we could do the typical analysis of batch processing and stream processing, then batch processing data will be complex to process and in comparison to the stream processing. Because in stream processing, it is basically used for doing the small calculation, for doing a small aggregation functions, like for sum, for average, for like that. So now coming towards the roles and responsibility. Now I have described the like basic terms about the data and the core concepts of the data. Now coming towards the roles, responsibilities, and jobs that are available in the field of data, in the world of data, we could say. So basically, if we could say, then we have three main roles. Apart of this, there are several other roles as well, but these are the main basic roles that are available in the field of data, and they had a good pay itself. So, like talking about data administrator role. So basically, a data administrator is a person who manages the whole database, who assigns the permission to the user, who stores the backup, who restore the data in case of failure, like who is the particular admin of the whole data. Okay, so you can work as your database administrator role or any database administrator role by going in the world of data. Then we have data engineer role. So data engineers are vital in working with data, applying data cleaning routines, identifying business rules, and turning data into useful information. So these are the particular roles that a data engineer will do. Okay, now coming towards the data analyst role. So data analyst is the person who converts the data into a visualized format, like who creates the data and who creates the data in visualizations, in on the graphs, in the charts, in that format. Visualize the data and pick up the trends and bring the insights from that data. So the person is the data analyst role. Now coming towards the concept of relational data. Now, here we'll start with our relational data and non-relational data. Okay, so relational data, what a relational data is. So as I have mentioned, that structured data is the one which is in the tabular format. So relational database contains all these structured data in it. So the relational data in database include the structured data that is in the form of the tables, in the form of the rows and columns, but arranged in a particular tabular format. Okay, so here we have entities of the table, like table entity. What an entity is? So entity is described as the instance, like for which the table is being held, for which the data is being held. Like for example, like in our school days or in our college, we have done that create table for customer, create table for employee. So what a customer is? Customer, employee, student, these all are the entities on which the data is being held over the table. All right. So table contains our rows, columns, and on a particular instance. Like rows contains the particular instance of the entity, and columns contain the properties, we could say. Okay. So data, it must be in tabular format, in relational data, and it should have primary key. Yeah, coming towards the primary key. So primary key is the key, we could say, which has not null values and which identify the whole each row in a table uniquely. Okay, then coming towards the foreign key. So foreign key is the primary key from the different table. It is the reference for a particular table, but it is working as a primary key for the other table. Now, for each value of the foreign key, there must be a primary key in the table. That could be a reference with. Okay, so coming towards the SQL. Now, how we could modify the queries? Like how could we work over the relational database on structured data? Like how could we do the changes, modification over the relational data? So for that, we have SQL. SQL is our structured query language. So structured query language is the language that we use for the modification. We could say inserting, deleting, updating, or modifying any rows, columns in the table. Okay, so like for example, I have taken here like two queries. Like first, here we have like queries for customer database. Okay, so here I have to print the all the details of the customer and from the table database customers. So have used select. Select is command used for to display the things that we want to display from the column and the rows. So here I want to display the customer ID, customer name, and customer address from the customers table. So all the customer ID, customer name, and customer address will be displayed from the customer database. Then I have another query. Like here I have used a where clause, like where we have different clauses, we have different commands for our SQL. Like it provides a huge number of commands to modify our data on our database. So I have used here where clause. Here the it is just like filtered. For filtering the query, we used where clause or other clauses. So here I want to print the order ID and product ID from the database orders where the customer ID is C1. So basically here here the order ID and product ID is displayed from the orders database where the customer ID is C1. So basically SQL is very easy language you can go ahead with because it just use the English statements that we have. So it just very easy to work on data by using the SQL. Next, we have relational database use cases, like where we use this relational database most of the time. So basically, as I have mentioned, that we use this relational database in the transaction process. Like most of the relational database is used in the field of transaction, in the field of e-commerce, in the field of banking. because here we have to maintain the whole data. We have to maintain a huge list over data. So we use in the field of banking, in the field of reservation systems, flight reservation system, online marketing, for a transaction. So there we use this relational database in most of the time. Now coming towards the relational data structures. Now we have studied that we use SQL for accessing the data. We have primary key, we have foreign key. So that was a particular thing about the data that we have in our tabular format. But is there anything else, like we can work over the queries, we can work over the data, like so that to optimize our working process? Like if we want to access any query from our by using our SQL from our database, then we are just using our SQL statements. But can we optimize it? So can we improve it? Yes, we can improve it by using these several data structures we have. Okay, so like for example, we want to access our queries from the database, so, within our within seconds. We want to improve the speed of the accessing. Then we use our data structures just to improve our accessing process, just to optimize our process. So we have, first we have indexing. Like there are several other data structures available as well, so I'm just talking about the basic data structures that we have. So like what is an index? So like as we all know that we generally follow the index in our books and notebooks. Okay, so like for example, in our book we have index, we just saw the topic and we just go to that particular page and just get our content within seconds. But if someone don't know to see the index, they just go randomly in selecting the page and just going to that particular content in several minutes. So like what is more optimized, that following index and just going to that particular page, or just scrolling the pages? So going to index and just going to that page will be more optimized. Okay, so similar is here. So here what we do is, first of all, like for example, I have taken here a query like select order id product id from orders where customer id is C1. So here from the orders table, I have made an index of customer ID. I have made an index of customer ID because here I have used a customer ID in my where clause. So I have made the customer ID as my index. Now I have to search that where I have customer ID as C1, I have to go to that particular row and then I have to print the order ID and product ID respectively. So here I have made the index of the customer ID, and I could see that there are 4 rows which is having the C1 as the customer ID. So I have to go there, I have to print the order ID and the product ID respectively. So in this way the indexing will work. So there are other techniques as well. Second, we can use a view. So what a view is, so like basically as I have done in indexing, like we have just made the index and we have searched accordingly. But in view, what happen is we basically make a virtual table based on the result set of a query. Like for example, here I am having a create view P1 orders as select customer ID, order ID, quantity from orders where product ID is P1. So like suppose I'm having a huge database of orders. Okay, orders database. Then from that I have to work over the product ID. So I'll make a virtual table of the product ID and have to search for the P1. Like in that virtual table, that P1 is there, and I have to go to that P1 and then I have to it will create a view of that P1, and then it will display the customer ID, order ID, and quantity on the accordance with the P1 product ID. Okay, so this is about the view. There are other techniques as well, and we can work on view as similar as we use on SQL. Like we just need to modify our statement little bit. It just we can access the queries by using a view in the similar way as we are doing with the SQL. Now coming towards the right platform for a relational workload, like a platform where could we do this relational workload and all the operations must be performed there well. So like we generally use this database and we have our system for that. Okay, but in companies, in big companies, there is a huge amount of data, and a company could not maintain a huge amount of data. Like for example, suppose that there is a data loss. In that case, the company have to pay a lot, because data is the most important asset for any company. So so a company has to move their data over cloud, because the data is in huge amount. Like for example, a Facebook is holding its lots of data over its cloud. Okay, so like that, so we have, there are several approaches for that. Like in general, we have three approaches: IaaS, PaaS, and SaaS. So what are these? So first of all, IaaS, it is the infrastructure as service. Then we have PaaS as platform as service, and then we have SaaS, software as service. So generally the companies doesn't trust the third party to store their data, because as I have mentioned, that data is an important asset and company can't afford to lose their data. So software as a service could not be a good option for a company. Like most of the companies didn't choose that option. So we have basically two approaches. First is our infrastructure as service, and second is our platform as service. So infrastructure as service enables us to create a virtual infrastructure in the cloud. That means here, like, we can work over our own device. Like we can maintain our, we can do manage everything. We just need to connect our virtual machine. We just need to add our virtual devices over cloud. We can connect to them. So here the Azure provides us this facility with as a service. So it will enables us to create a virtual infrastructure in the cloud that mirrors on the on-premises data center. Like here we can make our own data center by using this service. Second option is platform as service. Like some companies didn't want to manage the data; they just want their service at a quick instruction. So you then Azure also provides the service for that as well. Here the virtual machines, virtual devices, everything is added by the Azure itself. The company didn't need to manage that on their own. They just need to tell that what services they require, what things they require, how large their data is, and how all the users they are using it, and what all permissions they need. So that whole thing is managed by Azure itself. Now coming towards the thing that how it can be displayed. So we have physical, that we are maintaining a particular data on our own server, like we are handling it on our own device. So we have physical. Then we have infrastructure as a service, where the Azure will just connect the virtual machines over the cloud. Okay, then we have PaaS, that is platform as service. So here the whole the services and everything is, and virtual network, virtual machine, everything is managed by the Azure itself, and the person is, and the company is just accessing that using that services. So in this way we can transform our data from to the cloud. We can move our data to the cloud. Then we have concept of non-relational data. Now we have talked about the relational data, how we can modify it, what we can use it with, and like how can we do the changes, how can we move it to the cloud and everything. Now coming towards the non-relational data. Okay, so like non-relational data includes the semi-structured data as well as the unstructured data. So any data which is not in the form of the table, we could say, or not in the tabular format, then it is treated as non-relational data. So this semi-structured data, that is in the form of documents. So unstructured data, that is in the form of videos, audios, photos. So all these are included in the non-relational data. Okay, so non-relational data deals with the things differently, because here we don't have a particular set, because here we don't have a particular table to do the operations with. So here, like we here the each data is having its own entity. Each data is representing its own entity. We can just label them, we could say, and we cannot store it in a tabular format. So coming towards the types of non-relational and NoSQL databases. So as I mentioned that non-relational database data includes our structured, non unstructured data as well as our semi-structured data. So like there are different non-relational database management for that. So we use NoSQL here, like as we are using SQL for our structured data, for our relational data. So as we are using here non-relational SQL, that is NoSQL databases here. So let's see what a NoSQL is. So NoSQL is just a term for like non-relational SQL. So it is just NoSQL. So this NoSQL databases generally fall into four categories. It has four categories to store the data in different formats. For the data, it is that are available in the different forms. So firstly, we'll have our first categories, that is key value stores. So what a key value store is? A key value store is the simplest type of NoSQL. Like for example, you have your data, okay, so it just gets stored in a NoSQL database having containing two values. It will just have two values. One is your key, from which the data is being accessed, for which the data is being used to store. Then we have value. Value is contains the values of your data in the machine readable form, and it is opaque to data store. And it's the most important thing about this key value store, that these values are not visible to the data management system, like it is opaque for the database management system. And all the data processing and items are stored on the basis of the key order. Then we have our next category, document database. So here in document database, the documents are stored in the form of like in the database. Okay, so they are generally in the form of JSON format, but they can also be encoded in XML, YAML, JSON, or BSON. Okay, so here we have two things again, key and document. Document contains our whole data that we have, and key to access that data. But here the most important thing is that this document data is transparent to the database management system. Here it is visible to the database management system. But in the previous case, in our previous category, the data value is not visible, it was opaque for the database management system. Now coming towards the third category, that is our column family database. So here like we have two tables, customer table and address table. So here we have for particular row we have particular things, like for example customer ID 1. For we have customer ID 1, we have first name Mark, his last name is Hansen, and address ID is 500. Okay, so we have stored it in a column like customer, whole customer. So it will just mention customer ID, title, first name, last name, and address ID about it. Okay, and we have address. So address includes again address ID, then street address, city, state, and zip code. Okay, so customer and address, these are two columns here, like these are combined columns from the database we have. So it just store the values, it just store the data in the column families. So here it contains all the family and all the data in a particular column, and it treat it as a family. And here we can access it through the row key, we could say row ID or row key. Then we have our fourth category as graph database. So here in graph database, what happen is that suppose you have your data, like you have your tables and you have your things, like in like no in unstructured data we usually don't have table, but we can label it. Okay, so like for example here you have employee name Sarah. Okay, so Sarah works in the department name head office, and she reports to employee Max. Then again Max works to department sales, and then for Alok reports to the Sarah. Then Alok works in department marketing, and John reports to Alok, and then Alok reports to Sarah. So likewise here is a huge graph, like as we could not see that particular hierarchy of the data, but a graph of that data, like how a person is linked with the other things, like how a particular entity is linked with the other entities. So it will create a whole structure of the graph. Okay, so that's all about this. Now coming towards the data ingestion and processing. Now we are done with our relational data, we are done with our non-relational data. Now we are coming towards the data ingestion and processing. So what a data ingestion is? So basically, data ingestion is a method, or we could say a process, to transport our raw data into our destination, or we could say to our target, and without in processing, like in a raw processing. For example, here we can see that, like here we have raw data of critical device data, then we have financial transaction, we have point of sale data, and we are processing, we are just transporting this raw data. Data ingestion is just transporting that data into the data processing, which is further passed through data processing. Here the clean transformed data is further passed for the data exploration. Here the data is being processed, like the data that we don't require, it just go to dump, and the data that is important, that is useful, that is the information that is useful, is further used for modifying query, for applying queries, or for the visualization. So now see that how this transformation is done. Okay, so like for example, we have extracted our data. So we have our extracted data, we have different two methods for it. One is ELT and other is ETL. So firstly we are going to see ELT. ELT is extract, load, transform. Here, extract is E. That means we are extracting our raw data. Okay, we just extracted our raw data and we have loaded the whole data, whole raw data. But that is in a warehouse, like our private warehouse. Okay, and then we have transformed that data, and by doing the complex processing we have transformed that data, and we have collected a useful information from them, and we have done the data, and then again we have loaded it back. So this is the way how ELT works. This is the one of the way of loading and transforming. Next we have ETL. ETL is extract, transform, load. That is extract, transform, and load. So here, firstly, what happens is the data is extracted, then data is being transformed. Like data is being the useful data is being collected. So and the data that is not useful and like that is sensitive, then we can discard that data, and the data that we can use further or that we can transform is further loaded to the warehouse, and this warehouse is in the remote. Okay, so this is another way, the way in which we can transform and load the data. Now coming towards the data visualization. So like as we have heard that the data that we have used is further used as data visualization. So what a data visualization is? Basically, data visualization means that converting that particular raw data or information into a visualized form, into the form of graphs, charts, or we could say any line chart, graph, pie chart, or anything, so that it can make an impact over a user. Like we can't see, we like for example, we have a huge details of the sales, like we don't want to see the data and we can't match the raw data, we can't check the each row and column. But if it is represented in the form of a chart, in the form of a column chart, then we can easily visualize the how much sale have we have done, how much profit we have gained, so like that. So it will make a visualized impact and it will save our time as well. So here the same data visualization contains all the types of graphs, all the types of like charts we have. So here, like for example, the first is for like column chart, that is for volume of sales by retailer and store location. So here you can easily recognize all the data that we have. Then we have volumes of sales by month, that is, it is represented in the form of a bar chart or bar graph. Then we have line chart for that, volumes of sale by month. It can also be represented like this, like blue line is for this year and then red line is for last year. So we can see that is the sales easily. And then we have matrix, we can use it matrix like it is generally used in the stock market, so we can also use it. Then we have we have tree map, for that we have key influencer for that. So like these are the ways in which we can represent our data. So like it just depend on the industry that we are using it. Like for example, we want to see the trends, those trends can be seen in the form of charts or in the form of line charts, like that. Then we have this scatter chart, we have field maps, so we can see this as well. Like for example, for weather forecasting or for other data, we can use the field map as well, and we can use scatter chart as well. So like this, there are several other maps or charts available. Like we have pie chart, we have donut chart, we have like a graph, we have bar, we have anything. There's lots of categories we have. Then coming towards the data analytics. So basically, data analytics includes, like as I have told, that data analyst is the role to convert the data into the visualized form. The main role of the data analyst is to convert the data into the visualized form. So here it is talking about data analytics. Like how can we analyze that data for? Like the way we can use this information for. Like what are the insights that we are bringing from that data we have. So that analysis of the data includes the data analytics. But this data analytics is further divided into the broad categories that we have. Like there are several other activities that data analytics can have. Okay, so the data analytics activities includes the descriptive analytics. So descriptive analytics means it will help in answering the questions related to the historical data we have, like what has happened before, like on bringing the insights on the data we have for the historical data we have. Then we have diagnostic analytics. So diagnostic analytics is for helping in answering the questions like why these things has been happened. Then we have predictive analytics. So predictive analytics help answer the question about what will happen in the future for doing the prediction on the basis of the data we have, on basis of the data, and bringing insights from that data. So we can predict the future. We can predict the future from that particular data. Then we have prescriptive analytics. So prescriptive analytics includes the it helps in answering the questions that what action should be taken to achieve a particular goal or target. Like suppose a company wants to achieve a particular target on that sales, so it must analyze this particular prescriptive analytics to get the insights of that. Then we have cognitive analytics. So cognitive analytics helps to draw the inferences from the existing data and patterns. Like it just need to get the insights and inferences for existing data and patterns. Like you just need to draw the charts and other things for making them analytics, for analyzing the data. So that's all about the things that we are going to see. So I would just say thank you everyone, because I have not included everything here, like it's just a basic idea that I have covered today, and further we'll see tomorrow and the day after tomorrow in our further sessions. So I have quite resources with me that I have used today for these ppt and for the things that I have mentioned in my presentation. So like I will provide this in the chat box. So thank you everyone.
Um, Thank you, Jayashree, for such a lovely and wonderful session. It was very insightful, and I hope that every attendee attended it very well and they understood it very well. Thank you again for the lovely boot camp and for having as a speaker for our boot camp. Thank you so much.
Yeah, thank you, Tasha, for having me. I've just shared the few resources. Give me a second.
Like if anybody has a doubt, they can ask you if you, yeah. So if anybody in the attendees have any doubt, we have Jayashree with us right now, so they can ask right away and get their doubts cleared. There were doubts actually. Let me see. Yeah, what's one Sohail Rahman asked you like Last is connected to server, so can you address that?
Yeah, basically, I would say that we are talking about specifically about Azure. So, in the terms of Azure, we generally have the two options. Like logging as a service is an IT architectural model. Like we have it. Like we can use it as a feature we have. So, but not particularly for moving our the things over the cloud. We can't use it specifically. So for that, we generally have the two things that as have mentioned, that one is the infrastructure as a service and then platform as a service.
Yeah, I think that helped the student. Certificates, they will be provided soon when we will share the attendance link. Yeah, there's 3 day boot camp, so I think everybody has to attend 3 days. Then only they will get the attendance link for the same. So you have to attend all 3 days. Thank you again, Jayashri, for giving a lovely, very lovely session on cloud.